Okay, and welcome to another live stream. We have finished chapter 1. We're on to chapter 2, quadratics. And so let's get stuck into this one then. So chapter 2, quadratics, the objectives here. After completing this chapter, you should be able to solve quadratic equations using factorising the quadratic formula and completing the square. Read and use f of x or function notation when working with functions. I guess f of x notation. Sketch the graph and find the turning point of a quadratic function. Find and interpret the discriminant of a quadratic expression, and use and apply models that involve quadratic functions. I'm not sure I'll complete the entire chapter in this live stream, maybe just half of it, but we'll see how we go. Okay, so let's get stuck in. They have a bit of a prior knowledge check here, so you should be able to solve these equations. These are equations with, well, the first two have two unknowns, and then these are quadratics as well. So you can see this is all from GCSE mathematics. Factorize the following expressions, so you should be able to factorize quadratics. Even sketch the graphs of these equations. So these are straight line graphs, and then they also expect you to know the graph of y equals x squared. And even inequalities as well, so you should be able to solve inequalities. And there's a little note here: quadratic functions are used to model projectile motion. Whenever an object is thrown or launched, its path will approximately follow the shape of a parabola. Cool stuff. Okay. Section 2.1 is solving quadratic equations. A quadratic equation can be written in the form ax squared plus bx plus c, where a, b, and c are real constants. We know all of that already. To solve a quadratic equation by factorising, well, we've already talked about factorising in the last section. We worked through factorising quadratics, but now we're going to be solving those equations. So there's the extra step there of factorising and then solving. Okay, and then they give us some examples. So if you have a quadratic like x squared take 2x take 15 equals 0, look for the factors of 15 that add to negative 2. Sorry, I should restate that. Look for the factors of negative 15 that add to negative 2. And then you can see here they've found factors of positive 3 and negative 5. They're factors of negative 15. We can factorize it into two brackets, and then your solutions become negative 3 and positive 5. And we'll go through some more examples of those in a minute. Jasmina Katun, welcome. Thank you. Okay, and they also make a note, it's worth pointing out, that if you have x squared equals to 9x, do not divide both sides by x, because then you're actually getting rid of a solution. A possible solution to this equation here, x squared equals 9x, is x equals 0. So if you divide everything by x, you will not get that solution of x equals 0. So rather, if you have something like x squared equals to 9x, bring everything over to the left hand side, and then factorize the x out, and then you have either x equals 0 or x equals 9. That's something to remember. And what else? Okay, so these are further quadratics. So you can have quadratics with a coefficient of the x squared term, and then you have fractions as solutions. Okay. Alrighty. Some more examples. It says, in some cases it may be more straightforward to solve a quadratic equation without factorizing. So here we have some quadratic equations. 2x take 3 all squared equals 25. Rather than expanding those brackets out and factorising. Hey Yusuf, hello, hi, welcome. Rather than expanding out and solving that way, we can take the square root of 25 and we get positive or negative 5. And then you can get your solutions that way rather than, going through the whole business of expanding and factorising. Okay, let's get into some questions then. As I've been doing, I will do a few exercises from each and I leave the rest for you. So what I'd encourage you to do, if you are watching this, once I do a few examples and you get the hang of it, you can pause the video or just have a go at some of them yourselves, and we'll check the answers afterwards. So the ones that you do yourself, you can also check the answers to those. Okay, so exercise 2A we're doing. And these are basic factorize and solve the quadratic equation. So I will do maybe A, C. I'll do 3 of these, maybe A, C, and H. Why not? So starting with A, x squared plus 3x plus 2 equals 0. Hello Trevor, hello Righttree, hello VK. Factorizing, so look for the factors of 2 that add to 3. Well, the only factors of 2 are 2 and 1, and luckily they add to 3. So what we do is we draw our brackets in. When you don't have a coefficient of x, you can write your x's in straight away, and then we have 2 and 1, and I usually leave the signs to right at the end because sometimes you might have a negative and you need to figure out where you write the negative or positive, but in this case they're all positive, so we can just write x plus 2, x plus 1 equals 0. And then if you like, check that it expands out to x squared plus 3x plus 2. And then to solve this, remember if we have two numbers that equal 0, either a equals 0 or b equals 0. That's what we have here. We have x plus 2 times x plus 1. One of those has to equal 0. So we can say then x plus 2 equals 0 or x plus 1 equals 0. And then we have two equations that we can solve. So we can say then that x equals negative 2 and x equals negative 1. I'm never really sure whether to write and or because these are the two solutions for x. But I usually write or there and then and because this implies x plus 2 equals 0 or x plus 1 equals 0. And then these are our two solutions. Okay, C next. Hey Arvind, welcome. X squared plus 7x plus 10 equals 0. Sashimi, no problem. Thank you for joining in. Again, looking for factors of 10 that add to 7, and there's no coefficient of x squared this time, so we can write our x's in straight away. Factors of 10 that make 7, that is 5 and 2. Well, there are only 4 factors of 10, and we don't have to worry about 1 and 10, so it must be 5 and 2. And they're all positive, so we can write positives in the brackets. This equals 0. And then we have x plus 5 equal to 0 or x plus 2 equal to 0. Remember, one of those factors must equal 0. Then we solve these equations. If x plus 5 equals 0, x must equal negative 5. And then if x plus 2 equals 0, x must equal negative 2. Is there a list of stuff you'll teach in the future? So I am basically working through this textbook, so that's the plan, just to follow this. So there's the list. the chapters in the book. Okay. So that's part C, and then let's do H. X squared take 4x take 12 equal to 0. Looking for the factors of 12 the factors of negative 12 that add to negative 4. Well, first, what I usually do is just draw my brackets in. I know the first terms must be x, because we don't have a factor of x squared, a coefficient of x squared, sorry. Now the factors of 12 that make 4. I can think of 6 and 2, and if I have, well, I'm just going to write the 6 and 2 in, and then I need to think about the signs. So if I have a negative 6 and a positive 2, that's going to make negative 4. So these are my factors, x takes 6 and x plus 2. So then x equals 6 and x equals negative 2. You notice I skipped this step here. You don't always have to do this. It's good practice if you need revision, but at some point you can skip this step and just jump straight to the solutions. Okay. So I'd encourage you there to pause the video and have a go at the others if you want some practice. Okay, but I'm going to go through questions, all the questions on this page, and then check the answers after that. Okay, so on to question 2. Solve the following equations using factorization. Again, I'll do 3 of these. Let's see, I might do B, D, and F this time. B, D, and F. So B, x squared equals 25x. Remember, don't divide through by x because you're eliminating a solution there of x equals 0. So rather bring everything over to the left hand side. X squared take 25x equals 0. Then factorize the x out. So x factorized here would leave us with x take 25 equal to 0. And then my solutions are x equals 0 and x equals 25. Again, because one of these must equal 0 to get an answer of 0 between two products. And if x take 25 equals 0, x must be positive 25. D, 5x squared equals 30x. Bring everything over to the left hand side. This equals 0. Factorize the x, and also maybe you can see another common factor. You can also factorize the 5. So 5x is a common factor there. And this all equals 0. And now we have x equal to 0. So 5x equals 0, then x equals 0. And x equals positive 6. Last one of question 2, H. 4x squared take 16x plus 15 equals 0. By the way, if you're tuning into the live stream, feel free at any time to post other questions or ask me to pause on a topic and we can go into more detail or whatever. But as this is still kind of GCSE revision, I guess a lot of this you might already be confident with. But anyway, so this one here, we've got 4x squared take 16x plus 15. Now we have a coefficient of x squared. We need to factor that into the equation. Oh wow, Trevor Hung. Trevor Hung, you have the privilege of being my very first super chat. Thank you very much. Appreciate it. You'll go down in history, or in my history at least. Okay, so yeah, as I was saying, we have a coefficient of x squared of 4. Now, instead of just considering the factors of 15, we also need to consider the factors of 4. So there's like two different factorizations going on here. Factors of 15 are, well, 1 and 15, or 3 and 5. And factors of 4 are 1 and 4 and 2 and 2. What could we use here to make 16? I'm thinking of 2 and 2. So they're the factors of 4, and 5 and 3. If we multiply the 2 by 5, we get 10. 2 by 3 is 6, so that will make 16. Again, sorry, that's the wrong. We don't want the equal sign there. Again, draw your double brackets. And we have 2x. Those factors, they go in front of the x. So 2x and 2x. And the 5 and the 3, they go on the end. So I usually write those in, and then I think about the signs. So we want a negative 16. So both of these need to be negative to make negative 16. And then negative 5 times negative 3, that makes positive 15. So everything works there in that case. Please tell me about the book, Muhammad. So this is well, the title, I guess, is Edexcel AS and A-Level Mathematics, Pure Mathematics Year 1 AS. So this is, I guess, meant to be your entire Year 1 curriculum. These are the authors here. I believe they've written the previous Pearson textbooks for A-levels. I think some of these were authors of the core books when there was the modular curriculum. So they've gone ahead and written a new textbook for the new linear curriculum. Okay, sorry, I was finishing off this question. Where was I? Whoops, wrong one. All right. 1 year of college. Hang on. Yeah, this is year 12. Yes, so we're starting. We're starting off with GCSE revision basically. Okay, so we've got this result: 2x take 5 multiplied by 2x take 3. Then we have 2x take 5 equal to 0, or 2x take 3 equal to 0. And then we have solving this equation, add the 5 to the other side, divide by 2. This is 5 on 2. And we also have x equal to 3 on 2. Okay, so that was question 2. Again, I'd encourage you, if you want, to have a go at the remaining questions, if you want that extra practice. Yeah, so yeah, this is probably 9th, 10th grade stuff. We'll get in, as we go along, we'll get into some of the more difficult things. Okay, question 3. We have a bit of a mix of equations here. Which ones should we do? Maybe B, E, and H. Let's start off with those. So B, we have 2x take 3 squared equal to 9. And as I was saying before, rather than expanding everything out, there's a simpler way to solve this. We can take the square root of both sides. So if you take the square root of both sides, you'll be left with 2x take 3 equal to positive or negative 3. The square root of 9 is 3. And then we can solve this. So now we split it into two solutions. So we've got either 2x take 3 equal to positive 3, or 2x take 3 equal to negative 3. And then 2x equals 3 plus 3 is 6, and then x equals 3. Or we have negative 3 plus 3 is 0, so over here we'll have 2x equals 0, so x equals 0. And there are my two solutions there. Do H, yep, I'm getting to it. And which one was I going to do next? I think I said E. So 3x squared equal to 5. Here we could, I guess, divide the other side by 3. So x equals 5 on 3. And then x equals positive or negative square root of 5 on 3. Yeah, I think that would be the way I'd go to solve that one. And then, as I said, H next. So 5x squared take 10x equal to negative 7 plus x squared. Did I write that correctly? Yeah. Okay, well firstly we want to combine like terms. So 5x take 10x, we can simplify that to negative 5x squared because they are like terms. We're essentially doing 5 take 10. Bring everything over to the left hand side. So we also have a negative x squared because I'm subtracting that from the left. And we have a negative x and a positive 7, and this will equal 0. Then we can simplify further. Negative 5 take 1 essentially is negative 6x squared. Take x plus 7 equals 0. Now what I like to do is if I have a negative term in front of the x squared, I usually divide through by negative 1. You don't have to do this. I'm not sure why I do it. It's just I find it easier when I have a positive coefficient of x squared. So dividing through by negative 1, I get 6x squared plus x take 7 equals 0. Hello Arvind. Can you hear me? Is the sound good? And then, well, we've got a 1 in the middle here, so we need factors of 6 and 7 that make 1. I'm going to initially go with 6 and 7 as the factors. So 6x and x, and then 7 and 1. Keeping in mind where you write the 7 and the 1. If I write the 1 here, that means I'll multiply it by 6. If I write the 7 here, then it means I multiply it by 1. And now, can we make positive 1 with these factors? So if I have a negative 6 and a plus 7, this will add to positive 1. Okay, and then we need to solve it. So if this equals 0, 6x plus 7 equals 0, and or x take 1 equals 0, and then x will equal negative 7 on 6, and x equals 1. Okay, so that was my solutions for H. If you want to have a go at some of the others, I'm actually going to take a little break, so feel free to have a go at those if you want, and then I might go through and check the answers. Okay, so just a minute break quickly. Okay. Hopefully you had a go at a couple of those. I'm going to go ahead and check my answers so far just to make sure I'm not making any mistakes. And of course, you can always correct me if you're in the live chat. Feel free to pick me up on anything any mistakes I'm making. Okay. So where are we? Exercise 2a. I did A. That was -1 or -2. C was -5 or -2. Oh, so they say or in their answers. So I've been writing and, so that should be or. I'm not sure it really matters. H was 6 and -2. 2b was 0 and 25. So I'm looking over here, by the way, for the answers. D was 0 and 6. And if you did any of the other exercises, make sure you're checking those as well while we're here. H of question 2. H of question 2 was 3 on 2 and 5 on 2. 3b, x equals 3 and x equals 0. Office, sorry, I missed your question. Can a two-dimensional linear equation like this be directly calculated using the root finding formula? You mean the quadratic equation? Yes, we're going to get on to the quadratic equation in a minute, so if that's what you're referring to. Question 3e, positive or negative root 5 on 3, and h, 1 or -7 on 6. Okay, back to the questions. Where were we? Solving quadratic equations. We've got a couple more problems to go on this part, and then we're on to the next section. Okay, problem solving now. So question 4 gives us a diagram. And it says this shape has an area of 44 meters squared. Find the value of x. And they even give you a hint, which is nice. I'm not going to bother redrawing that diagram. I'll just leave it there, although I would encourage you maybe for the more complicated questions to draw the diagram out. It can really help. But for this one, how are we going to find this area? Well, as it says divide it in 2, so it's pretty much giving you the answer there. This square here had sides of x and x, so that area is going to be x squared, and then we need to add on the area of the rectangle there. And okay, so let's actually draw it out because it's going to just help my explanation a little bit. These lengths were x, this length was 2x, and this is x plus 3. And we divided it in 2, so this area was x squared. This area, well, the height is x plus 3. What would this length be? If this is 2x and this is x, well, we need to subtract that length from 2x. So this length here is going to be x as well. 2x take x is x. So the area of this rectangle is x times x plus 3. So the total area, let me bring this down a bit. Let me move this over here. The total area is x squared plus x times x plus 3. Let's expand out those brackets. So we'll have x squared plus 3x, and then 2x squared plus 3x. And remember, they tell us the area is 44, so we can say this equals 44. And then if we bring everything over to the left hand side, we will have a quadratic like we've just been working with. 2x squared plus 3x take 44 equals 0. I was just thinking, it'd be nice if they had more of these problem solving problems in here. Okay, so maybe I have to, for further exercise, I might have to get some more problem solving questions myself from somewhere and bring those in as well. So anyways, we have a quadratic here that we need to solve. So as we've been doing, look for factors of 44 and 2 that add to 3. Sorry, I always forget to say the factors of negative 44 and 2. So 44 is 4 times 11. For some reason I feel like that's going to help. And the only factors of 2 are 2 and 1. So can we make 3 with these? Maybe these are not going to work. What other factors could we use for 44? 2 and 22. It's not going to work. What else? What else makes 44? Oh, 4 and 11 does work. Whoops. 4 and 11 does work, of course. I was just thinking of 22 and 4. But of course it's 8 and 11 makes 3. So I'm going to factorize this to the first terms are 2x and x, and the last terms are, we need to multiply the 2 by 4, so the 4 goes on the end, the 11 goes at the end of this one, and then think of the sign, so we need a positive 8 and a negative 11. Sorry, the other way around. We need a positive 11 and a negative 8. So this will expand out to 2x squared plus 11x take 8x will be positive 3x and then negative 44. So then our solutions are 2x plus 11 equals 0, or x take 4 equals 0. This one over here is x equal to negative 11 on 2. Excuse me. Or x equal to positive 4. Okay. And the last one. Should we do this one, or maybe I'll leave that up to you to do later? PG accountant, isn't this stuff GCSE content? Yes, yes. So a lot of the year 1 A-level content is actually GCSE revision, kind of solidifying it, making sure everyone's really confident with it. Even the AS exams, the year 12 exams, they do have a lot of GCSE content in them. It's not till the second year that a lot of the newer stuff gets brought in. But we will be getting to some new content soon in this textbook. I might leave that one up to you to do, question 5. But let's check the answer to this one. Negative 11 on 2 and 4. Let's see. Where were we? 2. Oh, ooh. Critical mistake. Critical error. What have I done wrong here for question 4? I've given 2 solutions for question 4. Sashimi, exactly. You cannot have a negative. Thank you. So that would actually lose me a mark in the exam. If this was, say, a 2-mark question, I've lost that mark because I've given a negative as an answer, when in fact we can only have a positive here. So this is wrong, this one's correct. So there, what I've done is I've forgotten to answer the question. I've forgotten to go back to the question and read it carefully and realize that a length cannot be negative. Okay. So final answer there was x equal to 4. Alright, we're on to... Did I miss? Oh, this is... Yeah, so we're on to using the quadratic formula. So exercise 2b. Oh, Office had an answer for the other question, I believe. For this one. I'm not sure if it's an inequality. You could... Okay, well, okay, so I feel curious now. Let's have a go at this final question. So what I would do is square both sides. So 5x plus 3 all squared equal to 3x plus 7. I think that's probably the best place to start. And then I guess expand out, so 25x squared plus 30x plus 9 equal to 3x plus 7, and then 25x squared, that's 25 not 2, 25x squared is equal, plus 27x, take 2 equals 0, and what next? Factors of 2 and 25 that make 27, well that's going to be 25 and 1 and 2 and 1, right? So we have, if we, but that's not going to work because one of them's negative. Oh no, that's a positive 2, sorry. I'm not sure why I wrote negative 2, apologies. So this is all positive, and then we'd get the solutions of x equal to negative 2 on 25, or x equal to negative 1. Oh, I see what you were saying. Yes, the domain. Sorry, apologies for that. You were just saying that that 3x plus 7 must be greater than 0. Oh, yeah. So okay, so that's an important note, because if we substitute this one in, it would still be positive. So both of these solutions are still valid in terms of the domain. But yes, it is actually important to note that. Thank you. I was a bit slow there. Okay. Thank you, Maddest. Appreciate it. Okay. On to the quadratic formula. Some equations cannot be easily factorized. You can also solve quadratic equations using the quadratic formula. The solutions of the equation ax squared plus bx plus c equals 0 are given by the formula x equals negative b plus or minus the square root of b squared take 4ac over 2a. Again, nothing new here. You encounter this quadratic formula in GCSEs. And so you should hopefully be fairly confident with this. But it's always good to kind of revisit it to make sure that you remember all the steps and things like that. So they give us an example here. 3x squared take 7x take 1 cannot be factorized. There's no factors of 3 and 1 that make 7. So so you can go ahead and use the quadratic formula, plugging b in -7 where the b is, and a is 3, so plugging that in. You're essentially just plugging things into a formula and then solving. Notice they give the solutions finally as 7 plus root 61 on 6, or 7 take root 61 on 6, and then they also give decimal answers. So it sometimes depends on what the question asks. It might ask for decimals to round off, or it might ask for, or it might not specify. So you might be able to leave the answers as these solutions. Okay. So some notes. You need to rearrange the equation into this form before using the formula, and a, b, and c are called coefficients. Okay. Alrighty. Also, they note put brackets around any negative values, just to make sure you don't make mistakes with negatives and positives. Alright. Can I do year 2 at some point? I was thinking about the other day. I'm not sure how to structure it yet. I feel like maybe there could be one day per week where I do year 2 stuff, or maybe just an entire separate video on the year 2 content. I'm not sure how to do it yet. If you have any thoughts or suggestions, please let me know. Okay, question 1 says solve the following equations using the quadratic formula. Give your answers exactly, leaving them in surd form when necessary. Okay. Let's do A, C, and G. Why not? A, C, and G. So x squared plus 3x plus 1 equals 0. We can't factorize, so we go ahead and use the quadratic formula. I always usually write it down before I use it. Before I use it. This helps me to memorize it. So it's negative b plus or minus the square root of b squared take 4ac all over 2a. Let me just make sure I got that correct. Negative b plus minus b squared take 4ac over 2a. And then plug all of the values in. So b is the coefficient of x, so that's negative 3, plus or minus the square root of b squared, so 3 squared is 9, take 4 times a is 1, so if it's 1 I usually just don't write it. Also c is 1, so I'm not going to write a or c in there. And then 2 times a again is 1, so I'll just write 2 in the denominator. Then I'm left with negative 3 plus or minus the square root of 9 take 4 is 5 on 2, and we're essentially done, unless it asks us to give a decimal answer. But remember, the question said give your answers exactly, leaving them in surd form where necessary. So we're going to leave these in surd form. So x is equal to negative 3 plus root 5 on 2, or negative 3 take root 5 on 2. These are what you would call your exact values. Hello, Jeff. Username, check out the A-level channel, the dude on there said he has recorded a bunch of videos for year 2 and we're putting them out over the coming weeks. I haven't seen that channel. What's it called? A-level... Huh? A-level HUH? If there's a good channel, I can bring it up and we can all have a look at it. Hub. Oh, A-level hub. A-level hub. Maths. A-level hub. Oh, here we go. This one. So supposedly they're bringing out more A-level content. So if you want to check out A-level hub, sounds like they'll be having a lot of new content soon. Okay. All right. 1A, we're on to 1C. 1C. X squared plus 6x plus 6 equal to 0. Again, can't factorize, so we want the quadratic formula. This is negative b plus or minus the square root of b squared take 4ac over 2a. This reminds me of a really good YouTube video. I wonder if this will get copyright claimed if I play it. I'm not sure. I feel like he's an independent guy, so he hopefully won't copyright it, but we'll see. It even has the derivation of the formula in it.
New birthday party Oreo. Try it now, people.
Ads.
If you try to solve a quadratic equation, I promise you it's possible without any frustration. If you take everything, move it to one side, solve by x squared, x and the rest. Alright, now take the coefficients, name them a, b and c, and if you know the right formula, you will see that you get the solution in the very next step. Just sing the song in your head. Negative b plus or minus the square root of b squared minus 4ac over 2a.
What do we think, guys?
Negative b plus or
Have you seen this one before?
Root of b squared minus 4ac over 2a. Okay, let's start with our equation, and our job is gonna be solving
the
this
derivation.
now for x. So let's take minus c, multiply by 4a, and if you now add b squared, it all looks way too complicated. But don't be scared, just take a close look to the left side and you see there's a binomial formula with 2ax and b, so altogether this is the square of 2ax plus b, and now we have only one.
I mean, there's so many derivations of this formula, but this is one example. So you start off with the quadratic equal to 0, take c, multiply everything by 4a, add b squared. What this does is it allows you to create this this positive binomial squared.
1x, so the next step will be to get,
And then, so 2ax squared plus 2 times 2ax times b plus b squared, you can factorize that to 2ax plus b all squared. And over here you've got b squared take 4ac.
rid of the square, and if
and then take
The
square
right
root
side
of
is
both
not negative,
sides.
the square root must be one solution, but there's an alternative because minus is square
And then
root
you can
leaves
see
the
where
same
the
if you square
rest
it. So
comes
we
from.
write plus minus and now we are at the point where it only takes 2 more steps to solve it for x. And if you look to the left side, you know what will be next. Subtraction of b and division by 2a is giving us a formula for x. Okay, and it's negative b plus or minus the square root of b squared.
It's a pity this guy's channel is all in German, or a lot of his videos are in German, because I really like his channel. I think it's Dorfuchs. I think it's something like the fox or something in German. But yeah, a lot of his videos are in German, which is a pity.
Squared minus 4ac over 2a, negative b plus or minus the square root of
Abdullah,
b squared
welcome.
minus 4ac over 2a, negative b plus or minus the square root of b squared minus 4ac over 2a.
You've seen this video years ago, yeah.
Negative b
Not sure when this was
plus or
posted.
minus the square root of
Yeah.
b squared
It's got like 3 million views, so it's
over 2a.
pretty popular. Alright. $2016, yeah. Alright, so there you go. There's one derivation of the formula. Anyways, where were we? It's just got me thinking. Some YouTubers are just so creative. Like, you see some people that they can sing, they can make music, they can do everything. Anyways, it's kind of inspirational. Where were we? We were at 2. Which one was I doing? Question 1C. X squared plus 6x plus 6. We're plugging these values into the formula that we just saw the derivation of. B is 6, so this will be negative 6. That's a B, that's a 6. Sometimes my B's looks like 6's, which is difficult. B squared is 36. Take 4 times A. A is 1. C is 6. So anytime there's a 1, I usually just don't write it in. There's not much point. And then 2A is 2A is 2 times 1, which is just 2. Then we just simplify. So we've got negative 6 plus or minus the square root of 36. Take 24. That's 12. Square root of 12 over 2. And actually, you can even simplify this one further. If you write this as negative 6 plus or minus, well, you can simplify square root 12 to 2 root 3. If you write it like that, 2 root 3, we're going to be able to cancel a 2. So this is going to equal negative 3 plus or minus the square root of 3. So the solutions are x equals negative 3 plus root 3, or x equals negative 3 take root 3. That song is so catchy, yes, true. And then the other one I said I'd do was G. Okay. 4x squared take 7x equals 2. So we have to kind of write it in quadratic form first. So this will be 4x squared take 7x take 2 equals 0. Again, we can't factorize. There's no factors of 2 and 4 that make 7. So pull out your quadratic formula. Negative b plus or minus the square root of b squared take 4ac over 2a. Plug in the values. Negative 7 The negative of negative 7 is positive 7. Negative 7 squared is 49. Take 4 times a is 4, c is negative 2. And this is all over 2 times a. 2 times 4 is 8. And then simplify. So 7 plus or minus the square root of 49. Take all of this. What does this equal? This is 16. 4 times 4 is 16 times 2 is negative 32. But there's 2 negatives there, so that's going to be positive. So 49 plus 32, that's like 50 plus 31 is 81. Oh, and then we have a square number. What was I doing? 49 plus 32. Yeah, it's like 50 plus 31. Over 8, then this is 7 plus or minus 9 over 8. And so our solutions here are x equals to 7 plus 9 over 8, or 7 take 9 over 8. Hello Emma, thank you. Appreciate it. Welcome as well. Hope you get something out of these. Okay, so that was part 1, starting off with the quadratic formula. It's a kind of a neat solution, 7, 8, 9 there. I might do 2 and 3 and then go through and check the answers. Again, I'd encourage you at some point to go back and do the other questions in the exercise if you want more practice on these. Question 2. Hello Keegan. Question 2 says, solve the following equations using the quadratic formula. Give your answers to 3 significant figures. So last time they said give the answers exactly. This time we're going to have to get the decimal solution. Okay, so I might just do 2 of these, maybe E and F. E is 5x squared plus 9x. Take 1. Also, by the way, I was thinking this morning that it's not all going to be me going through textbook exercises. I might be doing different things at some point, like maybe if we get to different topics, I'll have different ways of going through them. But at this stage, this is just kind of me warming up and kind of getting into a routine, if you like. But so for 2e, again, can't factorize, so we need the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. That's me trying to sing that song. Sorry about that. Plugging everything in. Remember, b is the coefficient of x. This is negative 9. Positive or negative b squared. 9 squared is 81. Take 4 times a is 5 times c. c is negative 1. Over 2 times a is 5, so this will be 10 in the denominator. 2e. Sorry, I just lost my place for a second. Okay, then we want to simplify the term under the square root. So this will be 81 take 4 times 5 is 20. Multiplied by negative 1 is negative 20, so the 2 negatives make a positive. So here we'll have, we could do this in one step actually. 81 plus 20 is 101. Okay, so 101 divided by 10. I'm just thinking, can we simplify that third? Possibly not. Is 101 a prime number? excuse me. Is 101 a prime number? I can't remember. I can't think of any factors that go into 101. Anyway, I'm going to leave it as is because we need the decimal values of these anyway. So let's get our calculator out and we need to plug these in. So calculator, -9 plus the square root of 101 divided by 10. That gives me one solution of 0.104, and it says give the answer to 3 significant figures. So you look at the fourth decimal place, that's a 9, therefore you need to round the 4 up by 1. Remember, if it's 5 or more, you add 1 more to the number before it. So here we have x equal, we need to use approximation symbols. X is approximately equal to 0.105. Or we can also have -9 plus the square root of 101 divided by 10, and I've done the same thing. Oopsie. We need to do the negative this time. The negative, and then divide that by 10. That's -1.90, and we'll leave that as 0 because the next number is a 4, so we do not add 1 to the 0. So we also have x approximately equal to -1.90. Yes, we have to calculate these ones because it's saying give your answer to 3 significant figures. Yeah, it's kind of annoying, but it's fine. Okay, just one more of these. So f 2x squared take 3x take 18 equals 0. Quadratic formula. Sometimes I like to think, so could I possibly factorize this? It's worth checking because often, or in an exam, they're not going to tell you whether to factorize or not. So it's worth thinking about. Are there actually factors of 18 and 2 that make 3? So like 9 and 2, and then you will usually quickly realize there's not. But it's the reason I point that out is because if you're doing these type of questions, maybe it helps to recognize certain numbers that don't work together. I'm not sure if there's some kind of pattern you could look out for or not, but you know, if you think about it a little bit, maybe it helps. Anyways, quadratic formula, -b plus or minus b squared take 4ac over 2a. Plugging them in, -b, -3 is +3, plus or minus the square root of b squared, -3 squared is 9, take 4 times a is 2, times c is -18, and this is all over 2a, so 2 times 2 is 4. Okay, then simplifying this, and if you have to calculate it, you don't really have to simplify, but it just makes it easier to put into the calculator, I guess. So 4 times 2 is 8, times 18, 144, 9 take 144 is 1, so -135 on 4. Let's check that. So what did I do? I did 8 times 18. 8 times 18 is 144, and then I did 9 take 144. Sorry, it's a positive. I'm getting my signs mixed up there. This is a negative times a negative, that's going to be a positive, so this should be 144 plus 9, 153. make sure that you're always double checking your negatives there. And then we need to calculate them. So 3 plus the square root of 153 divided by 4, 3.8. So x is approximately equal to 3.84, or x is approximately equal to 3 take the square root of 153 and then divide by 4. I get negative 2.34. Negative 2.34. Okay. If you would like to go ahead and have a go at some of those yourself, I'm going to take a quick 1-minute break, and then I'll be back to check the answers to those.
Moi, mä valeäiti Hanne.
Whoa.
Tulin nopeasti vinkkaamaan, että jos oot ostamassa...
Don't know what that was. Oh, that was an ad. Yeah, so I'm taking a quick 1-minute break. If you want to have a go at some of those other questions in question 2, feel free. And then we'll check the answers. Okay. Alright, let's go ahead and check. Hello, Ebony. Do you have any videos that explain the calculation of simplifying with powers and letters? So index laws, I believe you're referring to. I do have a video on index laws. It's one of my early videos, so it's not super high quality, but if you go to my channel or if you search index laws, it should come up. Okay, so we're checking the answers to these. So we've done questions 1 and 2 so far. Alright, alrighty. And we're doing exercise 2B. Exercise 2B 1A was, they've written it slightly differently. They've written as half negative 3 plus or minus root 5. That's the same as saying negative 3 plus root 5 on 2 and negative 3 take root 5 on 2. So this is fine. C, negative 3 plus or minus root 3. So they're just writing it like this. That's fine as well. I'm not sure why I separated them out. I thought that's how they wanted me to write them, but just writing it like plus or minus is fine. 2, then G was 2. Ooh, something went wrong here. Okay, so this is incorrect. What have I done wrong? This is 7. This is 49 plus oh my god, what talk about a brain fade. Why did I write 7 plus 9 on 8? So obviously you can simplify this. 9 plus 7 is 16 divided by 8 is 2, and then 7 take 9 is negative 2 on 8, which is negative a quarter. Wowee. This is why you always check your answers. So of course, rather than writing 7 plus 9 on 8 and 7 take 9 on 8, there's no surds here. Simplify it to the actual answer. I'm sure you didn't need to be told that. I'm not sure why I left them like that. Okay. On to question 2. 2e 0.105 and negative 1.9 and f 3.84 and negative 2.34. And if you did any of those yourself, make sure to go and check those as well. Okay. It's frustrating when you make silly mistakes like that. We are still on the quadratic formula. So far we've done 2 exercises. Let's do a couple from 3 as well. So, question 3 says, for each of the equations below, choose a suitable method and find all the solutions. Where necessary, give your answers to 3 significant figures. So in this one, they're not telling you whether to factorize or use the quadratic formula. You can decide which one you want to do. So let's just do 2 of these. Let's do B and F. B, x squared plus 9x take 11. So for this one, we need to decide, can we factorize or not? So for this one, we need to think of the factors of 11. Are there 2 factors of 11 that make 9? Well, the only factors of 11 are 1 and 11, and we could either make 10 or 12 of those, not 9. So I think we're going to have to use the quadratic formula here again. And we also have to give the answer to 3 significant figures. Okay, so x equals negative b plus or minus the square root of b squared take factorial over 2a. b is 9, negative 9 plus or minus the square root of 81 take 4 times a is 1, so I'm not going to write it. Positive 1 I should say. If it's a negative 1 I usually do write it in. And then c is negative 11 all over 2a, which is just 2. So this is negative 9 plus or minus the square root of 81 plus 44. Negative 4 times negative 11 is positive 44. That will be 125, right? 125, 1, 2. And you could simplify this third, but as we're putting it into a calculator, you know, there's no real need to simplify the surds. So let me just double check that. 81 plus 44, 125. So then we have negative plus the square root of 125 divided by 2. That's my first solution. So x is approximately equal to 1.09, or x is approximately equal to negative 9 take the square root of 125 divided by 2. This is negative 10 point. Think about what we should do here. Look at the fourth significant figure, that's 9. If it's 5 or more, we round up that 0. So this is going to be negative 10.1. Negative 10.1. Okay. And then I said we'd do one more, which was f. Hopefully we can factorize this one. Factorizing is always more fun than using the quadratic formula. So here we have 6x squared plus 6 equals 12x. I've written it as 6x squared plus 6 take 12x, but I should have written it as 6x squared take 12x plus 6. Usually it's better to write the x term in the middle there. And then are there factors of 6 that make 12? That add to negative 12. So what about 3 and 2? If we did 6 and 6, that should make negative 12. So this one is hopefully going to factorize. Okay, so whoops, that should be a 2x.
I didn't get that.
Oh god.
Could you try again?
Siri is so annoying. Yeah, so 3x and 2x. And then the factors of positive 6 are 3. Sorry, we have to multiply the 3 by 2 and this 2 by 3. So we write that 2 on the end and the 3 at the end of that one. And then they both need to be negative to make negative 12x, but two negatives multiplied to a positive, so expanding that out we get 6x squared take 12x plus 6. Great, and then we can say the solutions are, well, 3x take 3 equals 0, so x equals 1, or 2x take 2 equals 0, so x is also going to equal, so we only get one solution for this one. That's interesting. I'm just wondering, is there a way to know that just looking at that quadratic? Oh, we could have divided through by 6. So if we take this quadratic and divide through by 6, we get x squared take 2x plus 1. Actually, okay. I'm not sure. I feel like there's something else that we could identify there, but it's slipping my mind. So anyways, just one solution there for that one. So if you get two of the same, you can just say x equals 1. And we're done for question 3. Oops, not sure what happened there. Okay, on to on to question 4, which is problem solving. So just a couple out of question 3. Again, I'd encourage you to have a go at the others if you want to. On to question 4, which is problem solving. Question 4 says the trapezium has an area of 50 meters squared. Show that the height of the trapezium is equal to 5 root 5 take 1 meters. So here's the trapezium. Here are the dimensions. This is x meters. The height is 2x meters, and the base is x plus 10 meters. And it gives a hint here, height must be positive. You will have to discard the negative solution of the quadratic equation. Something I forgot earlier, something that somebody in the live stream picked up. They said I gave a negative solution for length when it must be positive. Funny Sandri, welcome. You say please do a trigonometry class. We'll get there. It's chapter 9 and 10. We'll get there eventually. If you have something specific, towards the end of the stream I go through random stuff. So if you have a particular question or like a particular part of trigonometry that you want to go over, we could do that then. Okay, so we're trying to show that the height is 5 root 5 take 1. And we're given an area. So let's firstly create an equation. Remember, the area of a trapezium is the base plus the top plus the bottom the top plus the bottom multiplied by h divided by 2. At least that's the way I remember it. And so we can say this area is x plus the base, which is x plus 10, multiplied by the height, which is 2x, and this is all divided by 2. And this equals the area they give us, which is 50. Okay, so let's go ahead and see if we can simplify this. The first thing I would do is to get rid of these 2's here. So because they're multiplied, 2 is a common factor between the numerator and denominator, I can cancel that out. Then also we could simplify these, so x plus x is just 2x, and this is multiplied by x. I had an x left over there. This is equal to 50. Expanding these brackets out, I have 2x squared plus 10x equal to 50. And then I could divide through by 2 and also subtract that 50 from the left hand side. So if I divide through by 2, I have x squared plus 5x, and remember I'm subtracting that from the left hand side. 50 divided by 2 is 25, so I'd have negative 25, and this equals 0. And then we could, well, can we factorize, I guess is the question, are there factors of 25 that make 5? Factors of 25 are 1 and 25, or 5 squared, and neither of those will sum to 5. So we can use the quadratic formula. X equals negative b plus or minus the square root of b squared take 4ac over 2a. This is then negative 5 plus or minus the square root of b squared is 25 take 4 times 1 times c, which is negative 25 over 2. +25 plus 100 is 125 over 2, and then we have negative 5 plus or minus 125 we can write as, so the square root of 125 we can write as the square root of 25 times root 5. Remember your surge laws, we covered that in a previous session. The square root of 25 is 5, so this is, so root 125 is 5 root 5 on 2, and so that's the solutions for x. Which one will be negative? Clearly the negative solution there will give you a negative value for x, and remember we're talking about lengths, we want to get rid of that negative. So in this case, because x is a length, x equals, the only solution is negative 5 plus 5 root 5 on 2. And then remember the height is 2x. So if we multiply this side by 2, so to get rid of that denominator of 2, we can multiply it on the left hand side. We get 2x equal to negative 5 plus 5 root 5. Remember what they wanted us to show? They wanted us to show that the height is 5 multiplied by negative 5 take 1 in brackets. We can factorize a 5 out here and write those terms the other way around. We get 2x equal to 5 bracket 5 take 1, root 5 take 1. And that's the height, and therefore we've shown the height is 5 root 5 take 1. There you go. Okay, so there the answer is embedded within the question, which is nice. We didn't check these ones, so let's check question 3. To B, question 3. If you did any of the other ones, check those as well. So B was 1.09 and negative 10.1, and F was x equal to 1. Just one solution for that one. Okay. Where were we? If you are in the live chat, I'd love your feedback if you want to do the challenge. Should we give the challenge a go, or do you want to move on to completing the square? Please let me know. Challenge or no challenge? Maybe I'll leave that up to you to have a go at. Okay. Alright, it seems like we're leaving that one. Alright, we're on to completing the square. I was planning to make a video on this. I still will make a separate video on this eventually. But for now, let's briefly go over how we are completing the square. It says, it is frequently useful to rewrite quadratic expressions by completing the square. So x squared plus bx equals x plus b on 2 all squared, take b on 2 all squared. Oh yeah, so this is saying if you start with x squared plus bx, you can rewrite this as x plus b on 2 all squared, take b on 2 squared. Because if you expand these brackets out, this x plus b on 2 all squared, let's go ahead and do that. So you know how to expand double brackets. You think of it as two sets of brackets, and well, let's just write those out just to make it really clear. First, multiply the first terms, x squared, multiply the inner terms. This will be b on 2x plus b on 2x. Okay, let's write the whole thing out just so it's really clear. And then the final term will be positive b on 2 all squared. And then you notice these two terms cancel themselves out, and you're just left with x squared plus b on 2x plus b on 2x. Well, that's like half of b plus half of b. That makes one lot of b. So we've ended up what we started with, x squared plus bx. And I'm sure you've done this in reverse. You probably know the process of completing the square. This is kind of like an algebraic proof of it. And you'll see why we do this in a minute. We'll do some problems and you'll see why this is useful. But the main point is we can write x squared plus bx. Remember, these were the first two terms of our quadratic, x squared plus bx, b being the coefficient of x. We can change that into x plus b on 2 all squared, take b on 2 all squared. So these are our notes. Or actually, I'll just say note. And it actually has a geometric proof of this as well. You can draw a diagram of this process when x and b are positive. So here we have a rectangle with lengths x and b, and the area would be x squared plus b. The area would be this square plus this rectangle, so x squared, this area in here, plus b times x, this area of this rectangle. And you can rearrange any rectangle into a square. That's the point here. So they've changed this rectangle into a square with side lengths of x plus b on 2 and x plus b on 2. And then the area now is x plus b on 2 all squared. The whole thing, take this little square here, which is b on 2 squared. So the two blue areas are equal, and then this little orange area is extra, so we have to subtract that. And this is actually why it's called completing the square, because you create a square out of a rectangle essentially, and you just have a little bit extra that you need to subtract off. Anyways, I am planning on doing a video going into that in more detail. For now, we'll move on. So it says the original rectangle has been rearranged into the shape of a square with the smaller square missing. The two areas shaded blue are the same. So a bit of a geometric proof there. Okay. It gives us some examples. Complete the square for the expressions x squared plus 8x. Here they show you what this means in practice. You write x, you half the coefficient of x, so x plus 4, square those, and then take that term squared. And x squared take 3x, again, half of 3 is 3 on 2. X take 3 on 2 all squared take 3 on 2 all squared is the same as x squared take 3x. Okay, and let's see the usefulness of this. So here they give, do they give any context? Okay, they just give us this statement, ax squared plus bx plus c can be written as, if you factorize the a out, x plus b on 2a all squared plus c take b squared on 4a. It's really not, I think that makes it more complicated than it will be. You'll see after we do a few examples that, well, you'll get the idea anyway. So here it has another example. Write 3x squared plus 6x plus 1 in the form p bracket x plus q all squared plus r, where p, q, and r are all integers. So 3x squared plus 6x plus 1. Factorize the 3 out of those terms. So you have x squared plus 2x. Half that coefficient of x, so we have x plus 1 all squared in brackets. Take 1 squared. And then simplify. So you end up with 3x plus 1 all squared take 2. Okay, so this is an expression. Oh yeah, so because it is an expression, you cannot divide everything by 3. And all right, lots of tips here. Let's go ahead and do a couple of problems. We're doing exercise 2C. Question 1. Hello Abdi, you say, I'm currently year 12, moving to year 13. What advice do I have over the summer moving into year 13? Well, it depends what you want to do. If you want to do some revision, let's see. So I guess I would ask you what you got up to in year 12. So because of the lockdown and all of that, what sort of topics did you cover in year 12 would be my question to you, because that would give me some ideas as to what to suggest. Because I know a lot of year 12s, some didn't get any online lessons during the lockdown, some got online lessons every day, so it's been a real mixed bag. So if you can tell me what topic you got up to, or what sort of topics you covered, or maybe just the last topic you did, then I could give some suggestions. We missed out logarithms and a lot of steps, so we pretty much have done mechanics and pure. Oh, okay. Well, possibly catching up on exponentials and logarithms would be a good idea. And are you doing a mock exam for the end of year 12? Have you done it, or will you be doing it? That's my next question. Do you have an exam coming up, or did you do one already? Okay, so you're just doing one at the end of year 13. Yeah. So I mean, sometimes you'll have like an exam at the end of year 12. Some classes would be doing that. So yeah, you've said you haven't done logarithms, so I would suggest trying to teach yourself that possibly, or trying to get some help on that, or maybe go to a topic that you're confident with. If you're not confident like going to logarithms if you haven't been taught it yet, maybe go to a topic that you do feel you're confident with and then extending that into the year 13 curriculum. So maybe you did something like differentiation and you thought, okay, I'm getting the hang of this, maybe have a go at some of the year 13 content in terms of differentiation and calculus. That's in terms of pure mathematics. Mechanics, let's see. Where were we? So you said the last topic you did was kinematics. Sounds like you're a bit ahead. I guess that could be the same as motion, motion in 2 dimensions. Variable acceleration. Also, if you're not doing a year 12 exam at school, you could maybe have a go at the AS level exams yourself over the summer. That might be like have a go at one of the past papers, year 12 past papers. That might be a good idea. I haven't done any walkthroughs of those yet, but after the end of this I plan on doing one, so that might be something to consider. Okay. Alrighty. So we are completing the square. We've got one. I'm doing question 1 here. Complete the square for the expressions. By the way, hope that was helpful. Boat says past papers are the best way to revise. Yes, if you've done the content, if you've covered the content. It can be a bit daunting if you look straight away at an exam and you haven't done any of it. But yeah, once you've covered most of the content, I would suggest having a look at some past papers. Although don't look at all of them. You want to save some as unseen because it's really helpful to have a paper you can do fresh to really test yourself on what you would do in the actual exam. So make sure there's always a set of exam papers that you haven't done ready to do once you want to really test yourself. Okay, so 1A, let's do B and D. So B, we've got x squared take 6x. We want to write this in terms of x plus b on 2 squared take b on 2 squared. In practice, what this looks like is halving the coefficient of x, so this will be x take 3 all squared, and then take 3 on 2 all squared. That's all we're doing here. And if you want to go ahead and expand this out, just to prove to yourself, or maybe to get a hang of why this works, you could expand these brackets. You get x squared, take 6x plus 9. Ooh, what have I done? Oh, I've halved it twice. So this is just 3 squared. Apologies for that. Take 9, and then those 9's cancel. You're left with x squared take 6. Okay. Make sure you don't divide by 2 twice, like I just did. D is x squared plus x. The coefficient of x is 1, so we'd write this as x plus a half, all squared, take a half squared. And if you expand that out and simplify it, you will end up with x squared plus x. Okay, on to question 2. Complete the square for the equations. So here we have coefficients of x squared. It's going to make it slightly different, but not too bad. Again, I'll do b and d. Leave the others for you to do if you'd like. 3x squared take 24x. Factorize the 3 first. So this is 3 multiplied by x squared take 8x. And then do completing the square on this. So this is 3 multiplied by x take 4 all squared. So half of negative 8 is negative 4. And then we subtract 4 squared. And you can also expand the 3 out. So, oh, I should have written this one up here. I should have written this one up here as take 9. So then we can write this as 3 multiplied by x take 4 all squared take 16. And then expanding the 3, we get 3 multiplied by x take 4 all squared. 3 times 16 is 48. So 3 times x take 4 all squared take 48. D. Oof. Okay, so I was just thinking what I'm going to get up to. I might just work through this exercise, then exercise 2D, and that'll be it for today. Okay, so D, we've got 2x squared take 5x. Here we cannot factorize we can't evenly factorize 2, but we still have to factorize. We need that x squared to have a coefficient of 1. So factorize the 2 out. We get x squared take 5 on 2 x. And then use completing the square on this. So this is 2 times x take 5 on 4 all squared. Half of 5 on 2 is 5 on 4. Subtract 5 on 4 all squared. And then we have x take 5 on 4 all squared take 25 on 16. Oops. And then if you expand that 2 out to all terms, you have 2 times x take 5 on 4 all squared, and the 2 will cancel with that 16. That's meant to be a 16. This is 25 on 8. Okay. On to question 3. It says write each of these expressions in the form p bracket x plus q all squared plus r, where p, q, and r are constants to be found. Okay, so now we have 3 terms. Previously we've just been doing it 2 terms. Let's do it with 3. So 2x squared plus 8x plus 1. Complete the square on the first 2 terms. So firstly factorize 2. This will give us 2 multiplied by x squared plus 4x plus 1. and then complete the square on that expression in the bracket. So this will be 2 times x plus 2 all squared, take 2 squared plus 1 on the end. Then expand the 2 out. We have 2 times x plus 2 all squared. 2 squared is 4, so 2 multiplied by negative 4 is negative 8 plus 1, and then simplify further, we get 2 multiplied by x plus 2 all squared. Negative 8 plus 1 is negative 7. And I will do one more of these and then check the answers. So B is 5x squared, take 15x plus 3. Remember, factorize from the first two terms. So this is 5 multiplied by x squared, take 3x plus 3, and then complete the square on the terms inside the brackets. This will be x take 3 on 2 all squared, take 3 on 2 all squared, plus 3 on the end. And then expand the 5, so we would have 5 multiplied by x take 3 on 2 all squared, and then this is 9 on 4 multiplied by 5, that will be 45 on 4, so take 45 on 4 plus 3, and then we can simplify that as well, I guess. So 5 multiplied by x take 3 on 2 all squared. 45 on 4 plus 3 is like 45 plus 12. 45 plus 12 is 57. Sorry, negative 45 plus 12 is negative 33 on 4. Not sure about that one. Maybe I made a mistake in there somewhere, but let's go ahead and check. So going back to the top, we've got exercise 2C. One B. X take 3 all squared take 9. 1D. X plus a half all squared take a quarter. Yeah, I should have written that as a quarter. So, okay, fair enough, still correct, but I could have simplified further. 2b is 3 multiplied by x take 4 all squared take 48. And make sure you're checking your work if you did some of the extra problems. D is 2 times x take 5 on 4 all squared take 25 on 8. 3a is 2 times x plus 2 all squared take 7. And 3b is 5 times x take 3 on 2 all squared take 33 on 4. Alrighty. Again, make sure you check any of the other problems you did. Question 4, it says, has a little e next to it. That means it's an exam style question. I might leave that one up to you. Question 5 says, write 2 plus 0.8x plus take 0.04x squared in the form a take b x plus c all squared, where a, b, and c are constants to be determined. And also I'll leave that one up to you as well. This might look different, but of course it's still a quadratic. You can still follow the same method, and as long as you end up with some number in this form, a take b bracket x plus c all squared, you should be fine there. So good luck on those 2 and 3 mark questions. I've seen questions just like this in the A-level exams, and they're usually worth 2 or 3 marks. So if you can get question 5 there, then you know, that's a year 13 kind of exam level question. So there you go. All right, on to the next part. It says solve the equation x squared plus 8x plus 10 equals 0 by completing the square. So now we're using this skill we've just learned of completing the square. So we're using this stuff to solve equations. So remember, now we have solved quadratics by factorising, by using the quadratic formula. Now we're learning to solve them with the completing the square method. So 3 different methods here, and well, we'll talk about that in a bit more, but let's have a look at this example. It says solve this equation by completing the square, give your answers in surd form. So firstly, take that 10 over to the right hand side, use completing the square on the x squared plus 8x, and then get your solutions for x. So take the square root of the right hand side and then simplify, so you have x just by itself on the left. Hello AJ Maths. Hello again, I should say. Hello Go Pika. Alright, and then it says leave your answers in surd form. Okay, so now we are solving quadratics with completing the square. Here is another example. Okay, so this is suggesting divide by 2 to get rid of that coefficient of the x squared. So you'll notice in this example there was no coefficient of x squared, so we don't have to worry about that. But if you do have a coefficient of x squared, divide through by that. So if it's 2x squared, divide through by 2, so it's just x squared by itself. It's going to make it easier. And we can do this because it equals 0. So whatever we divide through effectively disappears. So this is saying this is an equation you can divide every term by the same constant to get x squared on its own. The right hand side is 0, so it is unchanged, and so on. Okay. Alright, so let's have a go at solving quadratics using completing the square. So this is 2D. Question 1. It says leave your answers in surd form, so let's do A and B. We've got x squared plus 6x plus 1 equals 0. Remember the process, we subtract that 1 from the right hand side. We'll have x squared plus 6x equal to negative 1. Then complete the square on the x squared plus 6. This will be x plus 3 all squared. Take 3 squared equal to negative 1. Then on the left hand side, we keep the x plus 3 all squared and we take that negative 3 squared over to the right. So 3 squared is 9, so we add 9 to the right hand side. Negative 1 plus 9 is 8. Then take the square root of both sides. We'll have x plus 3 on the left and positive or negative root 8 on the right. And then x is going to equal positive or negative root 8, take 3. And actually usually we write it around the other way, so I should have written this as negative 3 plus or minus the square root of 8. And they're your solutions. So comparing that to factorising, obviously factorising is the easiest or the most straightforward way to solve quadratics. But if you cannot factorise, this is another option on top of your quadratic formula. So rather than using the quadratic formula, maybe sometimes you would prefer to use completing the square. Okay, so let's do B. X squared plus 12x plus 3 equals 0. Okay, so we take that 3 from both sides. We'll have x plus 12x equal to negative 3. Then use completing the square on the x squared plus 12x. We can write this as x plus 6 all squared take 6 squared equal to negative 3. And then x plus 6 all squared equal to negative 3 plus 36. That will be positive 33. And then take the square root of both sides. This will be x plus 6 equal to positive or negative root 33, and then x is equal to negative 6 plus or minus the square root of 33. Okay, so that's A and B. I'll leave the other two for you if you like to do those. Question 2 says, solve these quadratic equations by completing the square, leave your answer in third form. Here we have coefficients of x squared. So there's an extra step to do here. I might do B and C. So B is 5x squared plus 8x take 2 equals 0. So what you want to do here is divide through by the coefficient of x. Even though it's not a factor of 8 or 2, we still want to get rid of it. So divide everything by 5. We'll be left with x squared plus 8 on 5x. Take 2 on 5 equals 0. And then we add that 2 on 5 to the other side. So this is 8 squared plus 8 on 5x equal to 2 on 5. You can see with fractions it gets a bit more complicated, but you can still follow the same process. So half of 8 on 5 is 8 on 10. So completing the square on this will be 8 plus x plus 8 on 10 all squared. Take 8 on 10 all squared equals 2 on 5. Then let's move these over a bit actually. Then we have x plus 8 on 10 all squared. 8 on 10 squared is negative 64 on 100. Oh, we can simplify that. So rather than writing 8 on 10, we could write 4 on 5. That's going to make it a little bit easier. So then we have 4 on 5 all squared equal to 2 on 5. And then x plus 4 on 5 all squared equal to, this will be 16 on 25. Well, let's just write the whole thing out. So 2 on 5 plus 16 on 25. To get rid of it on the left hand side, we add to the right hand side. And then we could multiply this fraction by 5. So it has the same denominator. This will be 10 plus 16. So we get x plus 4 on 5 all squared equal to 26 on 25. 10 plus 16 is 26. And then take the square root. So we've got x plus 4 on 5 equal to positive or negative square root of 26 on 25. You could simplify this to root 26 on 5. Which I might do actually. So this is positive or negative square root of 26 on 5. And then take that 4 and 5 from the right hand side. This is x equals to positive or negative root 26 take 4 all over 5 because they have the same denominator. Okay, wow, that was quite long. Let's just do one more. Hopefully it's a little bit shorter. So C, 4x squared take x take 8 divide through by 4, so this is x squared take a quarter x take 2 equals 0. Use completing, add the 2 to the other side. Well, you could do this in one step. Add 2 to the other side and use completing the square on this. This will be x take an eighth all squared. Take 1 on 8 all squared equal to 2. And then x take 1 on 8 all squared equal to 2 plus 1 on 64. 2 plus 1 on 64. So square that, add it to the other side. And then what is this simplified? 2 plus 1 on 64. If we multiply, so then we get 128 on 64 is the same as 2. So that's going to be 129 on 64. $129 on 64. And then take the square roots. So positive or negative the square root of 129 on 8. I'm just thinking if there's if I made a mistake, but I'm not sure. Okay, so take the square root, positive 129 on 8 plus an eighth. So I took the square root, added that 1/8 to the right hand side, and then I get x equal to, writing it around the other way, this is 1 plus or minus the square root of 129 on 8. Okay, so that was questions 1 and 2. Let's go ahead and make sure we're doing these correctly. 1a, 2d, 1a and b. So 1a was, okay, so you could write root 8 as 2 root 2. That's the same thing if you simplify that third. So I didn't fully simplify there. I'm still going to give myself the correct mark, but I guess you should always fully simplify if possible. B is -6 plus or minus root 33. 2b was a fifth, -4 plus or minus root 26. That's a different way of writing that, so that's fine. I think either way of writing that is fine. Hey Nishat, welcome. And C is 1/8 multiplied by 1 plus or minus root 129. Okay. There we go. I just wanted to check that because it's easy to make mistakes with these longer questions. All right. Let's do a few more completing the square problems. Oh, I'm on the wrong page. We're up to here. These are exam style questions. So question 3, it says x squared take 14x plus 1 equals x plus p all squared plus q, where p and q are constants. Find the values in p and q. Use your answer to part A or otherwise show that the solutions to the equation can be written in the form r plus or minus s root 3, where r and s are constants to be found. So this is asking us to do just what we are doing before. It's just the question is just written slightly differently. So I will leave that one up to you. Using that process, you'll be able to do that one. And then part 4 says, by completing the square, show that solutions to the equation x squared plus 2bx plus c equals 0 are given by the formula x equals negative b plus or minus the square root of b squared take c. So this is kind of getting to the derivation of the quadratic formula. And I might leave that one for you as well. The challenge says, show that solutions to the equation ax squared plus 2bx plus c equals 0 are given by x equals negative b on a plus or minus the square root of b squared take ac over a squared. And then it says, hence or otherwise show that solutions to the equation can be written as x equals negative b plus or minus the square root of b squared take 4ac over 2a. So this is how you can derive the quadratic formula. And again, I will leave that one up to you to have a go at, to experiment with. I think it's a good practice to try to derive that yourself. Okay, and we're up to 2.3. I think I'm going to end the going through the textbook there. I'll hang around a little bit longer if there's anyone with any questions that you want to talk about, any topics you want to talk about, then we can get into those. But I'll leave functions up for tomorrow to go through. So tomorrow we'll be talking about functions, what a function is, and finding the roots of functions. Okay. So for now, if you have any topics you want to talk about, any math related questions, feel free to post them in the chat. Otherwise, I do not have any other content that I'm going through in this live stream. Okay, sorry about that extended break. Oh, heavy music. Alright. Sashimi, hopefully you're still there. I just got your question. Let's see. So I need to download it. I need to open it. Then I need to copy it. And then drag it across. Where did it go? Somewhere. Nowhere. Oh, up here. Okay. Alright. Let's have a go at this one. Firstly, we have an identity to prove. So we have proved that sec squared take cosec squared is equivalent to tan squared take cotangent squared. I'm not sure which side to start with here. I'm just going to go with the left hand side because why not? So 1 sec squared, oh, that's not a good start. Sec squared x take cosec squared x. This is the left hand side. Okay, sec is 1 on cosine squared x. And the cosecant is 1 on sine squared x. What can we do with this? I guess find the common denominator. So sine squared x take cosine squared x all over cosine squared x take sine squared x. We need some kind of, maybe it'd be easier to start with the right hand side. Let's see, right hand side. Tan squared x sec 2x. So this would then, okay, let's try that. So sec squared equals 1 plus tan squared. Oh yeah, maybe that would be easier. Okay. Let's move this out of the way for now. Okay, let's try this. Uh, 1 plus sine squared x over cosine squared x. Take 1 on sine squared x. Um, mm, I don't know. Usually when I get stuck or I don't immediately see the next step, I just try the other one. So I'm just going to jump to the right hand side. I'll probably have to end up doing something with this eventually, but I'm just going to try something with the right hand side and see if it's any easier. That's my general strategy. So this is sine squared x on cosine, take cosine on sine. Yeah, that doesn't help much. I feel like I've done this one before. Mm, mm, mm. Oh, this one. Oops. So I'm seeing something I could do with this one. Oh. Oh, of course. Oh, thank you, Sashimi. Yeah. You're completely right. Yeah, that's probably the most straightforward way to do it. So cosecant is 1 plus cotangent squared. Of course. I'm guessing you already had got that part. And then this simplifies to tan squared plus take cotangent. Nice. Okay. So just to finish off this side, what I was going to do was do completing the square. So this is sine squared x take cosine squared x. And then you get 1 sine squared plus cosine over cosine squared sine squared. And then you can expand that out. This is what I saw anyway. And then that's your tangent and cotangent. Yeah. I didn't even remember to use those identities. But that's cool. That's a much better way to do it. All right, so that's part I, which you did yourself. Part 2 says part 2 says a y equals arc cos of x, and we have a domain and range. Part A says express arc sine x in terms of y. Ooh. Well, the first thing I see to do is we can say that cosine of y equals x. Then what could we do? sorry, the question is arc sine x. Well, let me write it around the other way. So x equals cosine of y. This is just the inverse of that. And if we take the arc sine of both things, what do we have? What do we still need to do? We need to simplify the right hand side. So we have arc sine. And we need that in terms of y, right? I guess we could, so remember that cosine of x is equal to sine of 90 take x, or is it the other way around? X take 90. No, 90 take x. So think of your, just draw any random triangle. Okay, let's do the 30, 60 right triangle. And this is 1, 2, root 3. So remember that sine of 30 is a half, and also cosine of 60 is a half. So we could also then say that the cosine of 60 is equal to the sine of 30. In other words, the cosine of x is equal to the sine of 90 take x. So let's substitute in here sine of 90 take x. You could also say pi on 2. Oh yeah, we should say pi on 2 because the range is in terms of radians. So we should use radians, not degrees. So this is pi on 2. And the arc sine of the sine, they cancel each other out. So the inverse sine of the sine of something cancels, oh sorry, that should be y, not x. Yeah, the inverse sine of the sine, they cancel each other out. So on the right hand side, we're left with pi on 2 take y. So express arc sine in terms of y, arc sine x is pi on 2 take y, I believe. And then evaluate arc cos x plus arc sine x. Okay, so this would be, excuse me, so part, what was this, part B, arc cos x plus arc sine x equals y plus pi on 2 take y is equal to pi on 2. Hopefully that made sense. Oh, great. Awesome. Something that I didn't go into detail on is why do we cancel arc sine and sine? Well, another way of writing that would just be to bring that arc sine over to the other side and say sine of something equals sine of that. So the sines cancel each other out. So yeah, I guess the trick there was to substitute in the sine of 90 take y for cosine y. Nice problem. So there's a bit of trigonometry for those that were asking for some trigonometry earlier. Leave that up there. It's funny I did all of this when I could have just done this for the proof. Yeah. It's important to remember all of your identities. There's often much shorter ways of doing certain proofs if you can remember the right identity. Okay. Alright. Just noticed the time. I think I'm going to head off. I've got about 5 more minutes. If anybody has any other questions, then feel free to post them. I still get marks for different proofs. No problem. Glad to help. And I love having a go at different kinds of problems. Thank you for sending that one in. Alrighty, I think I'm going to end it there. Thanks for tuning in. See you tomorrow. Bye for now.